Alright, in this video we're going to look at a new theorem, and this theorem is the triangle midsegment theorem. So we're going to look at what's called a midsegment, specifically for triangles, so that's why we have the triangle midsegment theorem. So before we talk about what the theorem actually says, let's make sure we know what a midsegment is, specifically in a triangle. So when you take two midpoints of two sides of a triangle, so D and E, these are both midpoints. E is the midpoint of BC. D is the midpoint of AB. When we take these two midpoints and form a line segment between them, this forms what we call a midsegment. Now, what the midsegment theorem tells us, first of all, two things. That DE and AC, these two line segments, DE, AC, that third side, they're parallel. That's the first thing that it tells us. The second thing that it tells us, and this is the one that's really more important for the application of how we're going to use what the midsegment is that DE is equal to half of AC. You need to make sure you take note of this. This is really important. This is what the midsegment is, and this is the relationship that is described in that triangle midsegment theorem, and this is what we're going to put into application in the next couple problems. So the first one, we need to assume a couple things first. Obviously a question it would be given to you, but for this video I'm just going to tell you the things that we need to know. We would first need to know that TU was the midsegment of QR, and once we know that, what can we use that for? Well, remember, the midsegment theorem tells us that TU is half of QR. The midsegment is half of that third side. Well, if it equals half of it, we know something about equality here, so we can set up and solve an equation, and in this equation we'll be able to find x, which will then help us find the actual measurements of TU and QR. So what I'm going to do is replace TU with the expression that we have here, x plus 1 equals, and I'm also going to replace QR with the expression we have here, 1/2 4x minus 16. And now we can solve this equation to find x. So I'll distribute. It's 2x minus 8 equals x plus 1. I'm going to move the x to this other side over here. We'll say 1 equals x minus 8. Add 8 to both sides. 9 equals x. So we could say x equals 9. Actually, let me move that over here. I'm going to use that space for something else. 9 equals x, x equals 9. Same thing. This one, it reads a little better because we read from left to right. Alright, so how can we use this information to find something about this triangle? Well, we can now use this, plugging it into these expressions to actually find the distances of TU and QR. So TU, we know, is x plus 1. Well, let's plug that in. 9 plus 1. TU is 10 units. We can also plug it into QR. QR is 4x minus 16. Well, 4 times 9, that's 36, minus 16 is 20. So we know that QR is 20. This also kind of helps us to verify our work. Midsegment is supposed to be half, so one of these should be half the other. And we do. We have 10 and we have 20. 10 is half of 20. So that's one way that we can use this midsegment theorem. So another way we can use it, this problem we're going to have to pull in a few different ideas and things that we have done before. But what I want to find here is the perimeter. And again, it's kind of the same idea as the previous question, where we're going to use that midsegment theorem to find some missing information about the triangle. But this one, instead of having expressions, we just have some values, and we're going to do some things to figure out what the rest of these values are. So we want to find the perimeter here of this main triangle, this main outside triangle. So let's look at a couple things. If we know that this is a midsegment, okay, meaning this is the midpoint and this is the midpoint, it tells us a couple things. First of all, it tells us that this is 10 because the midsegment is half of that third line. So if this is 5, this is 10. The next thing it tells us is that if this is the midpoint, well, this is also 6.5, making this entire line 13. 6.5, 6.5, that's 13. So now we have 2 of our 3 lines. But how will we find this one? Well, the only information we haven't used yet is the measurements of these angles. So let's go ahead and use these 2 angles to find this third one. Now remember, the triangle angle sum theorem tells us that all triangles have a sum of 180 degrees. So if we subtract that 67.5 and we subtract that 45, we will get the measure of this third angle. And if we do that, we get 67.5. Now you should notice a similarity here, and I'll use a different color to point this out. 67.5, 67.5, these are the same. Now one of the theorems that we talked about recently, right before I left, was the base angle theorem and the converse of the base angle theorem. And the converse of the base angle theorem told us that on a triangle, if the 2 angles on the base, so we'll call this the base, if those 2 angles are the same, then these 2 sides are also the same. So since those are the same, here and here, these are the same. And since this is 13, we also know this is 13. So now we actually have the 3 sides of this triangle. 10, 13, and 13. We can find the perimeter. 10 plus 13 is 36 units. And I'll try to make this a little clearer so it's kind of set apart from the rest of the page. Use a bunch of different colors on here so we know that's the perimeter, but the perimeter here is 36. So this is just a couple examples of the application of the mid-segment theorem.